I'm Montana. I use she, her pronouns. I am a senior here at Willamette and a chemistry and public health double major and biology minor, and I'm from Oahu.
My name is Daniel Fang. My pronouns are he, him. I am currently a senior at Willamette University, originally from Southern California area, Orange County. And I'm currently studying, I'm part of our chemistry department with a biochemistry focus.
My name is Madeline Kelm. I'm class of 22, which makes me a third year this year. I'm actually born and raised Salem, Oregon, and I'm a physics major at Willamette University.
Hello, everyone. My name is Graciela. I use she, her, ella pronouns. I'm a Bio-Spanish double major here at Willamette.
One of the first instruments that I got to use in the Chem and Bio department was the confocal. It's essentially the fanciest microscope I've ever seen in my life. And it essentially just fluoresces different cell samples that we have. And it makes them so beautiful, so resolute, and it was super exciting to use for the first time. Kind of scary, it's very expensive, but it's super fancy. And right now in the Chem department for my senior thesis, I'm using the brand new gas chromatography instrument that Professors Griffith and Williamson just got a grant for. Gas chromatography instrument is used to essentially take liquid samples that contain different compounds, vaporizes them, and runs them through a column to allow for analysis of what is in your sample.
There are tons of things that I could list for this, but kind of distilling it down into maybe 2 or 3 that I think have been really helpful over the past couple years. The first is that what's nice about the chemistry hearth area is that we have a computer lab right adjacent to it, tons of computers, and they're loaded with all the kind of softwares we need. So there's this thing called ChemDraw, which makes it really convenient to draw out easily organic structures, and it makes that whole process such a breeze. Stuff like top spin, which is basically something that we use to process different spectra, specifically for our other great resource, the NMR. I believe it's a 500 megahertz NMR, which is just a really fancy label to say that we can take really, really nice, clear readings. So that's really cool. And what's nice about the NMR is it's kind of there. As you start out, you probably have to talk to professors, because it's an expensive instrument and we don't want students just going in there. But right now I'm using it pretty independently now that I kind of have a handle on things. And yeah, not a lot of the other institutions have as powerful of an NMR for sure. Yeah, it's this huge magnet metal. It's great. It has its own room. That's definitely the star of the show. 100% that's the star of the show. It's a really unique resource that again, not a lot. If another institution has an NMR, which is a nuclear magnetic resonance spectroscopy instrument, big fancy name. Even though other universities might have an NMR, they don't have quite as powerful, most likely. So we have a pretty powerful one. We have all the kind of common instrumentation that you would need to kind of have a foundational knowledge in whatever branch of chemistry that is. So for our organic labs, we have all the rotovaps and glassware you need, rotary evaporators. I keep using the abbreviation, sorry. Rotary evaporators and all the separation funnels you might need, all that good stuff, all the glassware. We have UV, vis spectrophotometers, IR spectrophotometers, all the good stuff.
One of the facilities that we have is the bio hearth. So it's a room in the bio floor where you can go in, and there's some computers. There's also a printer and also some couches. You can hang out there. And it's really accessible to any student.
I guess so. There's 4 main parts to our physics department, I would say. So there's the regular classroom space where you have your typical tables and chairs. And then outside of that regular lecture hall, you have lab spaces, which are kind of near that first floor area. And so that's where you'll do class labs and whatnot. And so your basic physics tools are in there, computers and whatnot, ropes and weights and stuff to learn gravity works. And then the third part would be the labs that we work in. And so what I got to tour was Michaela's lab, and each of our professors has their own kind of lab in our basement area. And then on top of that, we also have a hearth, and the hearth is like one of the best places to be on campus, I would say. And so definitely pre-COVID, which is a good time, we had several tables set up, and so it was a mix of classes. And even coming in as a freshman, I was terrified to see a table full of senior physics majors all working on thermal physics or anything like that. But just coming in to sit down and kind of hearing them work on their homework or talk about their thesis projects was so amazing, and kind of threw me into physics more than I was expecting, but also was just like a great eye-opener. And so even, and then kind of like growing with that, our research projects would sometimes do research up there if we weren't in the lab, and it was great to kind of hear what the other research projects were doing. And so to integrate that kind of great atmosphere and getting to know, I guess, upperclassmen, I would say, the physics club and physics department are working on a newsletter to hopefully kind of promote that sharing of ideas, and hopefully we can get that up and running really soon. And then there is always still like tutoring options, and so for me, I've been a tutor and have been tutored, and so we all, like every night from Sunday to Thursday, I believe, there's physics tutoring offered online now instead of in the hearth. And so you still have a place to where you can go on Zoom and kind of do homework with others and ask people questions, and maybe you won't get as diverse of a people, or some people aren't able to go, but you still get to kind of like meet new people.
I used it in my first semester of second year. So once I kind of got familiar with school, I reached out to one of the biology professors and asked to join his research group, and he was like, absolutely. And it was an awesome experience. When you're starting off in the chem major, it's very hand-holding, making sure you're not breaking anything, making sure you're understanding how to use them fully. But in your third and fourth year, it's really, you know how to use them now, use them as you see fit and appropriate for your research and work that you're doing. Yeah. A lot of students that are just taking intro chemistry have access to like a wide range of different instruments, different pH meters, the NMR. There's like so, like I can't even begin to list them all. There's a lot of different instruments that like people that are not super familiar with chemistry or just trying to like get a taste of it have access to, for sure.
There is potential to use it, I think, as early as your junior year. Our organic chemistry TAs, they go in and process some of the spectra, which is basically just kind of like the graphical representation of some of the readings we're taking. So you can go in as early as your junior year. I know some students work with faculty members and help with them with their research, even starting out sophomore year, so that's a possibility too. Yeah, and as I mentioned, for me, it was more recently that I'm doing stuff independently, but I've used it previously.
So in the bio classes that we have, like the first day of lab, you have like your own like little cubby that you kind of claim. They'll give you a key and you can put in like your goggles or whatever you need for that class specifically.
One of the professors that I work closely with and have worked with for over almost 2 years now is Michaela Kleinart in our physics department. And so coming at the end of my freshman year, I approached Michaela, who all of our physics professors are super approachable, but I kind of just asked her if I could take a tour of her lab that's on campus. And she was more than willing to let me in and take a tour. And so I got to see basically like these huge lasers that we get to work with, and it was super, super loud, but super, super amazing. And she kind of gave me a lowdown on the 2 research projects that she's working on. And oddly enough, they kind of just really aligned with where I was headed post-grad too. And so I knew like I didn't want to tour any of the other labs on campus. And so I just kind of stuck with her, and I was like, I'm really interested in working with your lab. Here's my kind of like background, which was none except intro physics. And so that was really great, that even with just that small background or just some extra, small jobs that I've held around town, that she let me into her lab. And so starting my sophomore fall, I got to kind of start as a sophomore. And so I believe there were me along with 2 other sophomores, maybe a couple juniors and a couple seniors, just kind of within that lab group. And how it's structured is the few seniors that are in the lab group are primarily working on their thesis projects directly with this professor. So it was great. And then kind of down the chain link, I guess, we all contribute and kind of do research within those thesis projects, which is really fun. And so first semester I was kind of thrown in, and we focus on laser ablation. And so what laser ablation is we take those big lasers that I mentioned earlier and use them to drill little tiny holes or kind of like lines into the metal to see if we can make just regular pieces of metal hydrophobic. And so hydrophobic is like fearing water, water repellent essentially, which has been really cool. And so for me, that kind of looked like on a day-to-day was a lot of Python programming. And so I came in there with absolutely zero experience of programming, except, I don't know, I've done like Gmail. That's it's not even like programming experience, but so I kind of like threw myself into the deep end almost, but with the help of Michaela and all the other ones, they kind of taught me how to use the program, and not only how to use that, how to improve it. And so through that first semester, that's what I got to do. This last fall, we picked up that program once again and kind of improved it even more. And so we kind of cut our analysis data time. We analyzed our piece of metal and our droplet onto it, and we want to analyze the contact angles to see how hydrophobic that surface is. And we kind of went from one video taking us an analysis time of about, I don't know, depending on the person, around 15 to 20 minutes, depending on how many times you had to click, to like 30 seconds or so if the video was like super perfectly great. And so it was just like so amazing to work with such a great group of people. And especially in Michaela's lab, it is, I would say, more diverse in terms of like gender representation especially. And so I felt much more included as like a woman in STEM in that lab as well, which was super great.
Originally, I came here as a Japanese studies and an economics double major and switched. So I didn't get to look into a lot of these opportunities, but there are these things called RUs. Unfortunately, I don't really know the acronym off the top of my head, the full thing, but it's essentially just research opportunities at other universities, tons of places to go and check out various aspects of chemistry. At Willamette, we have SCRP, which is this kind of summer research program where you can work with a faculty member on their research, really get hands-on experience even before your thesis time. So yes, tons of opportunities.
So I personally was able to do some research with my advisor, Professor Craig. Some of the research, it was on like medical entomology, so like the study of like insects. I'm really interested in public health, so I wanted to dip my toes into that, especially since I haven't taken any public health classes, but I'm super interested in that. So I did some research on that, and I was able to build a mosquito trap from scratch with another partner of mine because I wanted to get some experience with like building and using my hands. So lab for this construction that we were doing. And then some other thing that I did with him was creating a pamphlet with some information on mosquitoes and ways to prevent getting bitten. And it was written in Spanish, so the Spanish speaking community could like see and understand of just following preventative measures as mosquitoes are like coming up north. It's because of like climate change. We can talk about that. That's like another conversation. But I've been doing research with him. I got an internship with a minority MH. It's a research training program, and so I was supposed to go to Argentina this summer, but because of COVID, I was unable to go. But I was able to do my internship Zoom, and we focused on the pandemic, and we created this survey for members of the Orange County community, and we were able to like launch it and get some data on people's. We were able to get more information on people's like housing situations, as well as their like perception of this, like of COVID, as well as the self-care practices that they were like doing during this time in ways that they were able to able to deal with a pandemic. So everybody deals with like things differently. So we wanted to better understand like what people were doing to like stay sane, I guess. So that's what I was doing this summer, and my professor, as well as other bio professors, were able to help me with writing my CV.
My first research experience at Willamette was with Professor Jason Duncan, and we worked, he has a Drosophila lab, so those are fruit flies, and he studies genetics with them. It was my very first immersive experience in research. I was super scared, didn't know what I was doing, but he was such a great mentor and really went through the methods that he used, the processes that he did, and taught me a lot of great basics. And then the following summer, he helped me to get an internship at the Mayo Clinic. So at that program, I studied biochemistry and molecular biology in the Department of Clinical and Translational Research with the dean of the school. And I was so scared, honestly. Like, you feel like you don't have enough experience when you go to like big programs like this, but I think just the training that I got here at Willamette and the experiences that I had, though I didn't know everything going into the program, really made me comfortable asking questions, looking for help, and it turned out to be a really great experience.
Facilities are really important, especially for students that just need some sort of space. For me personally, I'm from Salem and I do live at home, so having a space is really important to me because it's difficult to concentrate at home, and coming to campus, sometimes I don't want to go to the library. I want a space that's a little bit more quiet. So the bio hearth, like I mentioned before, is a great place to get some studying done, as well as any like group work that I want to do with other like potentially with other bio majors. But yeah, I like to use that. It's quiet, and if I need a computer, if I want like an extra computer, I have that, so I can use my laptop and the other like desktop computer available to me, so I can multitask. So it's been really useful, and then also just like easy for me to run into professors and ask for help.
I am working on my senior thesis now. I am conducting a exposome study, so I'm using silicone wristbands and necklaces to evaluate occupational exposures for cosmetologists. And I picked this project because my mom is actually a cosmetologist in Hawaii, so her and all of her like coworkers and friends that are cosmetologists essentially wore the silicone wristbands, which passively sample different chemicals that they're exposed to. And I'm using the GC, the new gas chromatography instrument that I talked about previously, to analyze the different chemicals that she's exposed to. Oh, absolutely. I think it really helps to solidify different concepts that you're learning in class. One of the classes that chemistry majors take is instrumental analysis, essentially analytical chemistry, and you're learning about all these different instruments and how they function, but to have them available to you to like use hands-on, to take that knowledge from the class to outside, is really helpful and makes students more competitive in different graduate applications or future research programs that they're interested.
Because it's so accessible, you have the opportunity to get hands-on experience, independent hands-on experience, relatively early on, as long as you talk to the right people. Like, if you talk to the chemistry faculty and you're like, hey, I'm really interested in figuring out how this whole NMR thing functions, like, can I go take a look at it? I can almost with like 99% certainty say that as long as they're not busy, they'll take you in and have you check it out. So definitely has helped.
I think that the formatting of some of the classes that we're taking are very unique to Willamette. For example, our experimental biochemistry class is really focused in instrumentation use and lab skills. That is really different from other universities that might have a separate lab course associated with the class or none at all. And all of the different instruments that we've been able to use are kind of countless, using like infrared spectroscopy, using HPLC. The list really just goes on, and to be somewhat comfortable and familiar using all these instruments is a really big advantage when you're thinking about graduate school or any sort of like research position post undergrad.
and we have a really well utilized hearth space. So we, like, even with like amongst your class, even between classes, like, you know people. It's a great community. There's plenty of dogs. So it's a very homey space. Essentially a space set aside to gather up with your friends and study, relax. A lot of them are equipped with like microwaves and fridge, so you can bring meals there too. And it's a nice place to gather up, not even if with people in your department, but just people outside of your department as well, and study. The kind of key feature of a lot of our hearths, though, is that we have faculty offices surrounding all of those spaces. And so, we can have a student who really needs help on this homework assignment, and they really wish they could talk to their professor. Lucky for them, their professor's office is right there, and as long as the door is open, they could very easily walk over and ask for help. So it's really nice. Just like I said, we have a lot of common instrumentation that you'll see, depending on, no matter what branch of chemistry you decide to go into, you'll see. So it's particularly those UV vis spectrophotometers, stuff like that, are like our rotary evaporators. You'll need either of those to go out into the real world as a chemist, and that's great stuff to put on your resume of like, I know how to operate these instruments. And what's nice about liberal arts education, and specifically the flexibility that Willamette provides, is that you can make those kinds of switches. Like, I don't think at a lot of other places I could have jumped from Japanese studies and economics to chemistry. Quite literally, I would say maybe the opposite ends of the spectrum. Very, very different. And so I'm really thankful to kind of that flexibility that our university provides.
I've definitely gotten practice. Like, I couldn't say that enough. So even with just that first semester of just some basic Python programming, I was able to, that following summer, get an external research opportunity at Texas A&M University. And even though there was COVID, I still got to do it online and whatnot. And so personally, what I'm interested in post-grad is oceanography and kind of applying physics to the ocean and kind of seeing what we can learn from that. And so even with just the experience with Python programming, I was able to take that along with a lot of the practical lab skills that I built in with the intro classes of Python, or intro classes of physics my freshman year, and kind of take those and mold them together into a resume. Also with just, I worked at a cake shop and I worked at our library just shelving books. And so even with those small experiences, it was like a great resume builder, and I was able to come in to those applications pretty strong with that resume and kind of that baseline experience. And then with the help of Career Center and all that other stuff, I was able to build great applications and even get some great interview skills or pointers, which landed me that job over the summer. And so I basically got paid to do what I love, which was the first time